So according to my records, we're ready for 4G, is that correct?
Yeah.
4G. All right, so what do you think? What property is there? 4G. Distributive. Yes, you're awesome. That's distributive. Works both ways. Factoring is distributive. How about H? That's a multiplicative identity. With your properties, get in the habit of linking them with an operation. So that is an identity property, but it's multiplied. So it's multiplicative identity. Good. Or mult-ID. You may certainly abbreviate. How about I? That's a little tricky. What's going on in I?
Multiplicative identity.
Not the identity, it's the, actually it's the inverse. It's the multiplicative inverse. When things cancel each other out, that's an inverse. Okay, and 1/5 and 5 cancel out, that's an inverse. All right, change the fractions into decimals and the decimals into fractions if possible. Okay, guys, this is it. How do we change 3/5 into a decimal? Okay, there's a couple different ways you can do it. Could you, since decimals are like tenths, could you multiply by, did everybody get this? Could we multiply top and bottom by 2 or by 20 if you like 100? That would be one option. What's another option? Maybe if the denominator is something like a 17 and that's not quite so handy. What's another, what do we do? Divide. You physically divide it, right? So if you can't turn your denominator into something that you handy that you want, you could divide. So what is 3/5? Either way, I don't care. 0.6? It's called a terminating decimal, right? 0.6. All right, what about 5/3? That was a little tougher to turn it into a 10 or 100 or something, so maybe we'll just divide that. What happens with that one? It's going to be repeating, and it's going to be 1.6 repeating. So we have a terminating decimal, we have a repeating decimal. Those are both examples of rational numbers, right? Terminating, repeating decimal. All right, what happens with -8/9? Well, go ahead and get your trusty calculator out. 8 divided by 9. But yes, it's repeating 8, for the 0.8 repeating. Now, that's not coincidental. Do you guys know the whole thing about it when you're divided by 9? No, that's when you, yeah, so look down at E. What fraction is 0.4 repeating gonna be? 4/9. Yeah. All right, what about 1.3? What's 1.3 gonna be as a fraction? 13/10, beautiful. You could also say 1 3/10. Mixed numbers are kind of a thing of your past. We don't do mixed numbers a lot, but it's certainly okay. I would say 13/10. What about F? Can you make that a decimal? No, not without rounding it off, right? Because F is an example of an irrational number. So it's √3/2, which just happens to be the sine of 60 degrees. Put that in your back pocket. All right, what about 0.24? Repeating. What do you think about that one?
24/99.
24/99. What a great guess. Try that on your calculator. Do 24/99 and see if that logic, her logic worked. It did, didn't it? Awesome. Now, I'm not too happy with 24/99 though, because why? It actually reduces. So step 1, 24/99, absolutely. But now we're gonna reduce that, so what's it gonna become? 8/33. All right, number 6, properties of exponents. I didn't label these, A, B, and C, sorry about that. What's this one? X to the what power? M plus N. Yeah. I want you to think about this. Memorizing the rules is great, and you absolutely should have an understanding of the rules. But if you had x to the fourth times x to the second, what does that really mean? That means you have 4 x's and 2 more x's, right? So what have you got? X to the sixth. Yes, you're going to add those exponents. That's x to the m plus n. What about the next one, the division? What's that one going to be? X to the m over, well, yeah, x to the m minus n. How about the next one? X to the mth to the nth, double exponent. What's that going to be? Yep, multiply those. How about x to the 0th? That's 1. Explain that to me. Why is that 1? Well, because we memorized that anything that is 0 power is 1. But where'd that come from? Think about this rule, or this rule right here. If you have x to the 7th divided by x to the 7th, everybody in the world knows that something divided by itself is 1, right? There's no question. That fraction equals 1. But what happens if you apply your exponent rule and subtract the exponents? You get x to the 0. That's why it's 1. All right, how about x to the negative n? 1 over x to the n. Perfect. All right, let's simplify it. Would you do the first 4? The first 4 are not too bad. And I will have you come up and put your answers on the board to A, B, and C, and D. I think I need to fix something there. I got a misprint there. I'm changing B. So go ahead and change B. I need somebody to come up. B is going to be this. That's what B is supposed to be. That's a game changer. Yes, that is. That is a game changer. Okay. When you feel like you've got one of these, bring it on up. Go ahead and compare with your neighbor first if that makes you more comfortable. But then let's bring them up and talk about them. You can do whatever one you want. It's a free-for-all. All right, all you guys that didn't come up to your board, we check this over. What do you think? You need to remember I changed the second problem, so he answered the second problem after I changed it. What do you think? Are we in agreement?
Yep.
Beautifully done. All right, let's step up the action here a little bit. Let's take a look at the next one. So let's be clear that there are lots of ways to approach these problems. So the individual steps may not match up, but our answers better match. Okay? All right, so what's your thought on this first problem? You're sitting there, you gotta do this. What would you do first? It isn't necessarily what everybody else will do first, which is fine. What do you want to do first?
Apply the exponent.
Combine the exponents. That, I like to do that too, like take care of these guys right here. So I have a 2 and a 3. Now, what's gonna happen here? We know that negative exponents switch places or move. So this is going to the top and this is going to the bottom. So I really have 7 of them on the top and 4 of them on the bottom, which is gonna leave me with 3 of them on the top.
It's
Then do
y.
straight
It's
x, y to the negative.
What?
It's different.
It's different on the paper. Well, I know it's not different on the paper. I wrote it wrong. Thank you for pointing that out. So that's not right. So the numerator is right, the bottom is 3xy to the negative 7. Okay, thank you. Well, I can still combine here, but now what's gonna happen? These are gonna come down, so I have x to the 5th, does that look better?
Yeah.
And then these are gonna come up, so I'm gonna have y to the 10th. Does that look okay? And now I got a square the whole shebang. So what am I gonna end up with? 4y 20 over 9x10. Perfect. Before I start, did I copy that one right? I thought I double checked both of them, but I can't remember. All right, here we go. What's that negative gonna do to this fraction? Flip it, so that might be a good place to start. You don't have to start there. Cubing everything would give me 8y cubed. Ooh, 7 cubed. That's not a number we do a lot. Is that 343? I got a calculator. If I don't know, I can get on my calculator. So there's my first fraction. Are we okay with that? All right, now, what a mess. That reduces, I'll make that 7 over 4. These go together, come down, x to the 4th. These switch places and simplify y to the 6th, or y to the 2nd. Oh, did I get all that right?
Yeah.
You agree? And it's not squared or anything, so that's just it, so that's what I'm multiplying, times this other one. Remember how we got 343? That was 7 cubed, right? So that's gonna cancel. That's gonna cancel. Okay, now what about the rest of it? How many y's? 5. How many x's? 7. Oh, that wasn't nearly as bad as I thought. I thought that was gonna be much worse. All right, try that last one. Last exponent problem. And somebody's gonna tell me the answer and hopefully we're all going to agree. Okay, who's gonna share an answer with me? What'd you get for your, this is the last exponent problem, what'd you get for the numerator?
Y to the 13th.
What?
Y to the 13th.
Y to the 13th? Alright, what'd you get for your denominator?
6x z to the 5th.
6x,
Z to the 5th.
x, 6x, z to the 5th? Does that look okay to everybody? We are in complete agreement? So am I. Okay, awesome. Alright, open intervals and closed intervals. What do you know about open and closed intervals? That's just new vocabulary. It's not new. It's vocabulary that you've had before. Tell me about that. What do you know? What do you mean by open intervals? What?
It's not including the number.
So, look on the number line, for example, we have 5 and a 7. It would look like this, right? That's an open interval. So it's all of the numbers between 5 and 7, not including 5 and 7. And the notation for that is the parentheses. Do you remember that? That's your notation. Now what about closed intervals? Same exact thing, only the 5 and the 7 are included. And what's the notation for that? The brackets. So this is kind of the difference between the symbols greater than, less than, and the symbols greater than or equal to, less than or equal to, right? It's whether we color in the dots or not. So, 9, it's so easy. You're gonna put a dot at -4, and you're gonna put a dot at 5. You're gonna shade in between and color in the -4. Easy. What about B though? What's B going to look like? It's gonna be, you're gonna have an arrow involved here. So here's the 6 with an open dot because it's a parentheses. And then which way am I gonna shade? Left, because it's kids negative infinities out this way. That's where negative infinity is. So C is gonna go from 7 closed dot to positive infinity, right? That's easy. In calculus, we write our answers as intervals, so we just need to get real comfortable with the interval notation. All right, 10. What are those inequality, or what are those intervals that we just sketched? What do they look like in terms of inequalities? So what would this look like if I had to write it with these symbols? It would look like this, wouldn't it? X is in between -4 and 5, and we have an or equal to on the 4. What would this one look like as an inequality? X is less than 6, and X is greater than or equal to 7. All right, interval notation. You're writing these in interval notation. We can fly through this. 11a, you got a bracket at 4 and a comma infinity. And remember, your infinities are always open. Remember that? They're always open, yep. And then the next one, we're gonna have parentheses at -6 and a bracket at 2. And the next one, the order is important. It's negative infinity, comma, -3. I hope our whole life is that easy. All right, scientific notation. What is scientific notation? What do we mean by scientific notation? I don't know, you know what it is, right? I'm not asking you for a definition. What's it look like? It's a number times 10 to a power, right? But there are some rules about it. One really important rule. Tell me about this number. It has to be between 1 and 10. That number has to be between 1 and 10. So it can be something like 5.2, but it can't be 23.8. It has to be between 1 and 10. Okay, so would you go ahead, knowing what you know about chemistry and all that stuff, would you go ahead and give A, B, and C a shot? Please do not type the whole thing in on your calculator, but you may do the arithmetic with the numbers on your calculator. Like in C, 7.6 times 8.8, you can do that on your calculator if you wish. But let's see if we can come up with the answers to this. Okay. I just put my first step up here. I have to take a closer look at these numbers. But I want you to double check my first step and make sure like 14.4, 0.5, 30.4, that I got the right numbers. There. And the right exponents for a first step. Remember, this is just my first step. Everybody get this to start out with? What's wrong with it? The number's too big. So I'm gonna have to change this to 1.44. Would you agree with that? Now what's that? I gotta do something. I moved it 1 decimal place, so that number's gonna change by 1. I just need to know, do I make it 19 or do I make it 21? What's your thought on that? 21. And I'm not sure what you're thinking about. You guys are all incredibly bright. You got all kinds of things floating on your mind. What I think about is whatever I write here as my final answer has to be exactly the same numerically as this. So if I take the first part of the number and make it smaller, then to keep everything balanced, the second half of the number is going to have to get bigger. So good. Now this one is the same problem, but the other way. This is going to have to become 5.0, which means it's getting bigger. So this is going to have to get smaller, but watch it, it's negative, so it's actually going to go to negative 12. Now you have your own ways of thinking about it. Did y'all get negative 12 as your final answer? I mean, that exponent is part of your final answer. And then this one, 3.04 times 10 to the 20th. How does that look? You okay? All right. I don't think we need to worry about 14. You can all do this, can't you? Change these numbers. You're good at that. So P1 done. That homework will be due on Tuesday. Let's start P2. Let's start labeling things. Again, this is just vocabulary, all review, all easy. Just make sure we're all on the same page. So here we go. What do we call this guy right here? Y. This is the y-axis. Yep. What do we call this one? This is your x-axis. What do we call this point right here? The origin. And one thing I gotta share with you is that we call that the origin in this coordinate system. But there are other coordinate systems, one in particular that we're gonna study big time later on in the year. And that point will have a different name, and these won't even be there. So just be aware, that's the origin in this particular coordinate system. Okay, these 4 sections are called quadrants, and this is quadrant 1, 2, 3, 3 and 4. What is the name of this coordinate system? Anybody know? What's this called? This whole thing right here, what's that called? It's called which coordinate plane? Good guess. It's called the Cartesian coordinate plane. Have you heard that word before? Have you heard of René Descartes, one of the great mathematician philosophers? The Cartesian coordinate plane. And that's where the x and y. So anytime you have x's and y's involved, you're in the Cartesian plane. He is credited with like putting all this together and kind of bringing together algebra and geometry so that we could actually draw numbers. That's what this does. Okay, so draw a scatter plot. So just plot those points. I have absolutely no doubt you can do that, so we're going to skip that. Absolute value. Now, as future calculus students, we need to have a different vision or better understanding of what absolute value is. Okay? So, can somebody tell me, we're going to define it right here. What is the definition of absolute value?
How far away a number is from 0?
Okay, that's the intuitive meaning of it. How far is it from 0? That is exactly right. That is on the number line. On the number line. That's exactly right. That's not the definition, but that is exactly how we're going to use it. What else can you think of? What's the absolute value of 5? 5. What's the absolute value of negative 5?
5.
So, if x is a positive number, then its absolute value is itself. Would you agree with that? But if x is a negative number, then its absolute value is the opposite of itself. Now when I write that, that always freaks people out because absolute value is positive. Yeah, it is positive because x is a negative number. And if x is a negative number, then the opposite of it will be a positive number. That's the definition of absolute value. There are certain problems that we can't do on the number line. We're going to look at a bunch of problems we're going to do on the number line today. But when you have a problem that you can't do on the number line, thinking about distance on the number line, you are going to need to use this definition. Whatever you're taking the absolute value of, if it's positive, then it's just itself. If it's negative, then it's the opposite of itself. All right. So, how did you do a problem like this? This is 4A. How did you do a problem like this last year? Or the year before, or the year before, I don't know. How do you do problems like this? So did you make it like 2 things? So you said x minus 4 equals 5, or x minus 4 equals negative 5? Does that look okay to everybody? Totally okay. That will give you the answer. But as calculus students, we're going to try this problem a little bit different way. All right? So let's look at a number line. Just the random number line. Here's a 6, here's an 8. If I said, what's the distance between those two, what would you do? Subtract. Now, here's the deal. If you take 8 minus 6, all is well. But what if you do 6 minus 8? Then we need to take the absolute value of it, right? And if we take the absolute value, it doesn't matter which way we subtract, it's all good. So the distance between these two numbers on the number line is the absolute value of their difference. The absolute value of the difference is the distance. Okay, so let's come over here and let's look at this for a second. Now this will work. I'm not telling you you can't do problems this way. What I'm telling you is when you get to calculus and start talking about the definition of limits, you need to have some understanding of what I'm trying to get you to see here. The distance is the absolute value of the difference. Well, look what I have right here. What do I have right here? I have an absolute value of a difference. So I'm going to draw my number line. I'm going to put my 4 right here. And all I know is that there's a number out there, and its distance from 4 is 5. That's what this says. My number's distance from 4 is 5. So that number could be 5 units this way, which would make it 9. Or it could be 5 units this way, which would make it -1. So the answers to the problem are -1 and 9. And that's exactly what Mr. Blanchett would have gotten if he solved his little equations. It's okay to do it your old way that you're comfortable with, but try to help. Do you see how this is? It's so nice, and it's going to be so valuable to you. So let's do the same thing with the next one. Let's try it from an absolute value or from a distance standpoint. Now this one's a little bit trickier because if we're thinking about distance, it has to be a difference. It's gotta be a minus. Okay, so how am I gonna finagle this then? What am I gonna do to get around that? Can I think of this like that? So now it says the distance between some number and -2 is more than 6. Okay, now wait a minute. The distance between some number and -2 is more than 6. So I'm going to go 6 this way, and that would put me at 4. And I'm going to go 6 this way because I don't know which way to go. I can go either way. And that will put me at -8. These 2 points are where the distance is exactly 6. Where's the distance going to be more than 6? Out here? One of the things I don't like about your method, Mr. Blanchett, and it's fine, it'll work, use it, okay? But one of the things I don't like about that is you have that whole and or thing, right? And we teach you that, okay, if it's a less than, it's an and, if it's greater than, it's an or. But we don't really, why is that? I mean, that's just a piece of useless crap to memorize. This is why. Because if you're greater than 6 away, you have to be out. If we made this a less than, do you see why you would be in? That's why. That's why it all works. Okay, yep.
Do we keep it on the number line as our final answer, or do we change it?
No, a good, Bryce, thank you. No, the answer for this problem would be everything from -infinity to -8, or everything from 4 to infinity. This, you guys used to use in the U's. The U's are the or. Whenever your graph is in 2 pieces, you have to use in them.
What would a situation be where you use the and?
You don't, because if, let's look at one real quick. If this had been, we'll just use the same number. If this had been less than 6, we're still gonna count out, so we're gonna have a 4, we're gonna have our -8, okay? But this time, the distance is less than, so it's gonna be all those numbers right there. That's there's one piece to that graph. It's the interval from -2 to 4. That's it, that's the answer. So you're never in interval rotation gonna be popping in intersections, because it's covered in there already. All right, anybody else? Those are great questions. Great questions. All right, so now we're gonna practice a little bit. Write as an absolute value. Okay, so we're gonna write it so it looks like this, or something like that. The distance between x and 6 is 7. Julia?
The absolute value of x minus 6 equals 7.
What do you think, class? Yep, she's an all-star, perfect. That's exactly right. This is a distance. Distance must be a difference. So she said x minus 6, and it is 7. All right, what about the distance between negative 3 and x is less than 5?
Absolute value of x is 3.
X plus 3? Okay, I just got done saying it has to be a difference. That is a difference, right? It's x minus negative 3, and it has to be less than 5? The distance between x and a is at least d. Oh lordy. Okay. Josie?
The absolute value of x minus a is greater than or equal to d.
The distance between x and a is at least d. So doesn't that mean d or bigger? What do you think? I think she's right. I think she's right. How do we find the midpoint of anything? Whether we're on the number line or not, how do we find the midpoint? Average, just average them. So the midpoint of 6 and negative 9 would be what? Negative 3 halves? Negative 1 1/2. Midpoint of negative 2/3 and 7. Oh goodness. Who wrote these problems? Would that be 19/6? Double check my arithmetic. If I add negative 2/3 and 7, I get 19/3, but then I have to average it, so divide by 2. Does that look okay to everybody? All right, now we're gonna look at the distance formula, the midpoint formula, and find some distances, midpoints, perimeters, circles. Oh golly, this is huge. Okay, here we go. Distance formula, anybody remember it? Don't get all hung up on the subscripts and stuff, guys. How does the distance formula work? We subtract our x's, subtract our y's, square each pair and add them up. That's it, take the square root. Midpoint, you just told me, midpoint is average. So you're gonna add your x's, divide by 2, add your y's, divide by 2. Nobody ever in your life is gonna say, write the distance formula. Nobody is ever gonna ask you to write that down. You just have to be able to use it. So make sure you understand how it operates. All right, so we'll do problem 8A. We're gonna find the distance and the midpoint. All right, so here we go. Drew, what are you writing down on your paper? You're back there busily working. What are you writing?
I'm filling in, so I have 4 minus negative 1 squared. And then plus 3 minus 2 squared.
Okay. Interesting enough, someone did that already once today. We need to talk about that for a second, because whether we're doing distance or midpoint, our x's are together and our y's are together. So we're going to do that subtraction, but it's not going to be within the ordered pair, it's going to be between the ordered pairs. So 2 minus negative 1 and 3 minus 4, how does that look? Does that look better?
Yeah, that's
Okay. By the way, let's not get all hung up on order here, because since we're squaring, it's not gonna matter. if I do 2 minus negative 1, I get 3. If I do negative 1 minus 2, I get negative 3. But when I square, I get 9 either way, so it doesn't matter. Did you get root 10? All right, any question about that? Square root of 10 is your answer. Everybody good? All right, let's find the midpoint of the same 2 points. What's that going to be? Emily, what you writing down? Is Emily writing? What are you writing down here to find your midpoint?
Negative 1 plus 2 over 2, and then 3 plus 4 over 2.
Perfect. Some of you probably don't even write this stuff down if you do it in your head. Did you get 1/2, 7/2? Perfect. Easy, easy, easy. All right, let's skip down to number 9 now. Find A if M is the midpoint of AB. So think about A, here's point A, here's point B, and right in the middle of them is point M. M is negative 3, 6. B is 2, 4. Tell me how you're going to figure out point A. Raina?
2 plus x divided by 2, and then
So Raina, thank you, Raina. Stop right there for a second. Raina says, I don't know what point A is. I'll call it X, comma, Y. And then I'm just going to use my midpoint formula. So 2 plus X over 2. And, well, what does that have to equal? 2 plus X over 2 has to be negative 3. Right? Someone nod? Okay. And then 4 plus Y over 2 has to be 6. Does that make sense to everybody? So what do we end up with? We get negative 5. No, we didn't. We got negative 8. Did we get negative 8? And then we got 4 plus 1. Did we get positive 8 for that one? That will work 100% of the time. 100% of the time, that will work, assuming you do your math right. It will work, everything will be fine. I want you to think about something though for a second. How far did I travel in getting from 2, start right here at this point, in getting from 2 to negative 5, from getting 2 to negative 3, how far did I travel? Negative 5. So to get, remember they're equal, so to get from here to here, I have to go another negative 5. From 4 to 6 is up 2, so I need to go up another 2, so we can do it more geometrically too. The formula will always work, but so will the geometry. Find the area and perimeter of triangle CHS. All right. What are you thinking about this? Now, obviously, I've plotted my points. Feel free to plot them if you wish. It's perfectly okay. I don't want you to become over-reliant on the sketch, though, because they're not always to scale, and you're going to have notebook paper. You have to be really careful. And it's not necessary, but it's certainly okay. If you're uncomfortable with this, go ahead and actually physically plot the points. Our job is to find the perimeter in the area, though. So we can just get an accurate picture. How do we find the perimeter? We need this distance, and this distance, right? So you guys here, you guys are gonna find CS. You middle guys are gonna find find SH, and you guys over there are gonna find CH to save some time. So we're doing our distance formula. So whatever 2 points that you are using, do the distance formula. I got Route 41, Route 41, and Route 82. Anybody else get those? Is that what we got? Okay, so what's our perimeter? Our perimeter would be 2 Route 41s plus Route 82. Now, that doesn't reduce. I know it happens to be 2 times 41, but that doesn't, if you're gonna reduce it, you need to have 2 factors, right? Of 2. So that would be my perimeter. Okay, that was easy. How do you find the area of a triangle? 1.5 base times height? You know, that's real cool, except I gotta know what the base and the height are, right? We are incredibly lucky in this problem. Actually, the guy that wrote the book written this problem, so this would happen. Is it true that Route 41 squared plus Route 41 squared is Route 82 squared? The true statement? What's the square root of 41 squared? 41. What's the square root of 82 squared? Is that a true statement? So if the Pythagorean theorem works, the triangle is a right triangle. And if it's a right triangle, then it had, I know what the base and height are, they're the 2 sides that make the right angle. So since this is the hypotenuse, wouldn't this be the right angle right there? So my base is Route 41 and my height is Route 41. So my area is 1/2 Route 41 times Route 41, which is 1/2 of 41, which is, well, 41 halves, or 20.5 square units. At this point in our lives, that had to be a right triangle for us to do the problem. Because the only way you have of finding the area of a triangle is 1/2 base times height. We are going to learn like 5 other ways to do it. So we won't need to know that. We'll be able to do that no matter what these sides are when we get a little bit farther along. Everybody okay with that? Tricky. It's one of those things you got to be on the lookout for. All right. Prove that the diagonals of quadrilateral PQRS bisect each other. All right. I want you to take a minute with your partner. Oh shoot! I don't know if we have a minute. A minute's about all that we have. All right. I want you to think about that one over the weekend, and we're going to come back and hopefully go through that quickly, because we have got to get done with this section. So yeah, look at number 11. That's your little mini assignment. Look that over. See if you can figure out a strategy